All right, I think I should start. Hello, everyone. So I'm going to talk about vector visualization in this talk. Um, so first of all, I want to talk about just briefly what vector plot is, just so like people can understand the rest of my talk. And vector plot is not something new. It has been in the product for a few versions, but in 12.1, I think we introduced a bunch of options that make vector plot much easier to use. And that concept is extended to other vector plot families. So I want to talk about that. And I would give a list of the visualizations that we have been working on that is vector plot related. And then I'll talk about these new options in detail, especially the vector points, which is the main topic here. Um, so first of all, what is vector plot? I mean, if you are familiar with vector plot, this is just maybe this is just a refresh for you. So this is a picture that I just got from the internet. And it is something that we all can relate to. So when we were young, we were asked to draw the magnetic field of a magnet. So the way we do that is just we play this magnetic compass, and then we just see how the arrows is pointing. And well, I'm certain that we didn't have this many compass when we were young. But if you do place that many of compass under the magnetic, then you will see all the arrows is pointing from the positive to the negative. And the vector plot is just a perfect tool to model this. So here I have a vector field that represents this. So there are two particles. I mean, simplify the magnet here into 2 points. One is on the positive, which is x minus 2, and the other one is x plus 2. And one has positive charge, one has negative charge. And this is the field, how it looks like. So if I um, substitute the x and y with the position, and I will get a vector. So this is the vector that we want to visualize. The way we visualize this is we put an arrow at the position, and the length of the arrow, that in this version, we made them a unit length. So they are all the same length. So what we are trying to visualize with the color is the magnitude of the vector. So that is why the legend here is 4. So with higher value here, um, that means the higher magnitude it is. And you can see that this is representing the magnetic field on the right. So that is the vector plot. So once again, so we are trying to visualize the vector field. And for every point x comma y, we have a vector. And the arrow is the direction of the vector. And the color is the magnitude of the vector. And another popular plot in conjunction with vector plot is the stream plot. And the stream plot is essentially solving this differential equation. So what this differential equation is saying is that, so for a given point, the tangential of that point is exactly the vector, right? So if it's just like, the speed of a position, that's the definition of that. And so that is what we have here. The derivative of the x and y is the vector of that point. So by solving this differential equation, we can get x of t and y of t, and that is continuous function that we are drawing in the stream plot. Okay, so with that established, we can look at the new options that we introduced for vector plot. So the first one is the vector points. Vector points is just that an option that you can specify to say that how I want to sample the vector field. So remember, the vector field that we provide for the vector plot is a continuous function. I mean, what I meant is that the whole field is continuous, but if we want to um, visualize this vector field, we have to have some sample points. So that is controlled by the vector points. So say that we have these points placed in the field. And like I said before, by default, we are making the vectors the same length. And the packing of these points becomes important. So we have the maximum vectors in the field. And each vector is packed in a way that it is not touching. And that is that when they are all the same length. But that is not the only thing you can do. Certainly, you can say that I want the length of the vector to represent the magnitude. In that case, you can use vector sizes to say that what is the minimum and the maximum vector length I want to have. And the other one is just how you want to change the look of the vector by specifying the vector aspect ratio. So this is just purely aesthetic. So by default, like I said, we do not have any vector scaling. So that's why all the vectors have the same length. But you can enable this vector scaling, and then you can see this is actually the traditional view that we previously had. Then you have a different length on the vectors. So that's controlled by vector scaling. And we also introduce vector range. Vector range works just like plot range, except that it's not on the x and y. It's actually on the magnitude of the vectors. And this vector range works well with the clipping style. Say that I specify my vector range for this vector plot so that I'm only showing a range of vectors. And the clipping style is controlled the clipped away vectors. So I'll talk more about this later. And another option is vector markers. We have quite a few vector markers. They have been there for few versions, but we also make them. We also introduce some control system so that we can place the vectors in different way. I will talk about this in detail. The other two options Brett has talked about, which is very straightforward, is the region boundary style and region filling style. That is implying that vector plots and its family can take a region function. And we will see that. All right, so these are a bunch of vector related visualization functions we are supporting. So we vector plot, stream plot, vector density plot. So this is the density plot itself is a continuous representation of the vector field that is overlaid on the background. And then we have the 3D version of vector plot 3D, and we have the slice vector plot 3D, which is a volume plot. That is that I have the whole vector field in 3D, and I only want to visualize a slice of it and how the vectors is flowing on that slice, and that is using this function slice vector plus 3D. We also have GeoVector plot and GeoStream plot that Nemo has talked about. So I will not go into the detail, but they work just like the vector plot. The data input is slightly different, but they are all well documented. The other two that I will not talk about is complex vector plot, which is vector plot, but we are visualizing the complex value, and the complex stream plot, because there will be talked by my colleague Tim McDavid at I think 12, no, I think at 1 o'clock today. So let's move on to the options we that's the main topic of today. That is vector points. So how we sample the vector fields is the key point to have a quality vector plot. So say I'm plotting this vector field y minus x, and the simple way I can sample this field is I create a grid, which is just on the integers, and I can just put the grid in the vector plot. And that's actually how it was before. And in the 12 that we introduced a few different packings that I will talk about in just a few minutes, in just a few seconds. But I want to also mention that this vector points allows you to specify not just on the integers. You can specify any random real points. So for example, so these are the points that I want to sample my vector field, and I would just put that points into the vector field, and these are the vectors as the positions as the points are. And like I said before, this color is coded by the magnitude of the vector. And there isn't really a good way to know what the magnitudes are if you are not actually computing the magnitudes outside of vector plot. So one of the I think the best way to know that is calling these plot legends out, and then you can see what's the magnitude. And this becomes very important when you are using the vector range. And there are situations that you do want the vector length to be represented by the magnitude of the vectors. That is one. That is the time that you use vector scaling, go to automatic. I'll talk about more of this. So besides that, we also have the functionality that you can say that I want to sample the vectors, the vector field over a region. So here I have a joint region, which is 2 disks. So it's directly inside the arguments of x comma y. And we can also, like I said before, this is a spatial function, the slice vector plus 3D. The vectors is actually sampled on the service only. And this service is controlled by the second argument here. This is a preset one, which is called center cut sphere. We have many presets. So if you open up the documentation of slice vector plus 3D, there are a bunch of there you can look at. So let's move on to the sampling method. By default, we are using hexagonal in, I think, since 12.1. Before, it's using the regular one. Now we are using this more tightly packed version. And we also have a method called mesh for the 2D I will talk about. And for the 3D, we have hexagonal, and we have something called face-centered cubic. It is a different packing algorithm. They look very similar to the hexagonal, but if you look closely here, they are actually different. The difference is subtle, but I'm sure that there will be some cases that you would want, one over another. And like I said before, all these vector functions, they accept that the free-form points. And to nicely see that hexagonal, how packed it is to use this vector markers, circle, arrow. So it just draw a circle around the arrow. So you can see that they are tightly packed. And the mesh is based on the geometry of the corresponding surface. So if I'm plotting the magnitude of this vector field in the plus 3D, this is what I get. And if I call the mesh out, you can see that there are tons of meshes in this surface. And the sampling method, vector points go to mesh in a vector plot, is based on the meshes in the plot 3D. We thin them out so that they don't look overwhelmingly complicated. But the reason we introduce this is that there are cases when you have a region, the region will look more like the region if you have the samples sampled at the mesh points instead of regular grid. The other function that we have is the vector. Another function we have is a vector density plot. So in this case, if I plot this with the same field here, and you can see that this is a nice representation of both of these vector plot and the plot 3D. The vector points, besides that, you can say that I want this hexagonal. You can also specify what how many vector points per direction. So like here, I say that I want 10 points on the x direction and 10 points on the y direction. So I've changed to 15 here. Then you can see that the y direction has more vectors. And the vector lengths get shrunk a little bit so that they still have the tightly packed packing. And we also optimized so that the number of the vectors sampled has taken aspect ratio and image size into consideration. So this will be in 12.2. So this is going to be helpful when you have different, x and y ranges. And in the 3D, like I said before, the difference is it's kind of subtle. You probably won't just observe it, from the output of this. But but I think you'll just have to take my words. They are different. Right. So we'll just take a quick example on the 3D version. So this is the same idea. I have two particles. This is in the 3-dimensional space. And the static potential is just like this. And if we draw the contour plot, then I can have these ISO services of the potential and at different ISO values or contour values. And if I draw the same vector field in the VectorPlot 3D, then I have a bunch of vectors. And if I put them together here, then I can visualize how the vectors, how the vector field look like, and how the potential field. The reason I'm choosing this example from the documentation actually is because we can now just use select a slice VectorPlot 3D and to see that just in one function. We do not need to generate two different plots and put them together. So this is the same thing. So besides the preset slices, I can use actually any Boolean function on the second argument. This is the ISO services. Okay, so another option is vector range. Like I said before, it works like a plot range, but it's on the magnitude. So for example, in this vector field, the vector's magnitude get exponentially growth on the corners. So and that's why you see mostly blue in the center and yellow on the corners. So in order to use vector range, we really need to know what the ranges are. So that's why I bring up these plot legends. And now I can say that the vector range I only want to show from 5 to 200, and that is rin. And I just saying that my clipping style is go to none. But I can say that my clipping style go to red below 5 and blue above 200, and that's how you get the colors. So that's very straightforward. So right, and with the same example, I'm going to show off the option vector scaling. So vector scaling, the reason we have this is that the reason we turn it off is that if we turn it on by default, this is what you get in a plot that has high values on the magnitudes. I mean, the difference is high. The majority of the vectors is going to be invisible, and that is not desired, because apparently there's some interesting behavior here, but they are just saturated by the high values on the corners. So that's why we turn it off by default. But I mean, even if you, you can set that I want the scaling to be log. Even in this case, it is still difficult to see what happened in the center. So with scaling function go to vector scaling go to none, you can have all them be shown, and we use the color to indicate the magnitude. Okay. All right, and this is another options that you can change the look of the vector plot, and this is called vector markers. So by default, we are using just the arrows. These are the points I previously generated. But like I said before, you can have much more other marker values that we can have. I'm just taking a few here with the arrow, the circle arrow, double arrow, or just dot arrows. So what I'm going to try to show you another thing is that we can actually, so if I do the epilogue of the point here and points. Oh, I need to put the primitive here. So you can see that this is how the vectors are placed. But the problem of this is that there are some applications that you do want the arrows to be placed in the beginning or in the end. The way to control that, you can use place and say start. Then you can have the arrow placed at the beginning. If you do the end, it is on the end. So this is going to be useful for you if it's for any reason you don't want it to be centered. All right. The last set of options is region filling style and region boundary style. Like I said, they are very straightforward. They are very useful when you have region functions specified in the vector plot. So I'm taking the same examples as the first slide. And here I say that I only want my vector field be sampled in this region, which is outside of these two circles. There you have it. And by default, there is a region boundary style and there's a region filling style. I can turn them all off, then you get this. And besides the region function that you can specify, like I said before, you can also specify within the argument that is the X and Y. You can specify I only want to visualize within this rectangle. And here I use these two options to stylize them. Together, if I put them together, this will has a beta representation of that the very first slide that I have shown. So this is an application of this region filling style and region boundary style. That will conclude my talk. So all these options is going to be applied in the vector plot, all these vector plot families. So there's still a few kinks that we are still working out for 12.2. So and we are continuously working on the new options in the vector plot families. So if something that is not working in 12.1 for you with these options, it might have worked in 12.2. So I just want to point that out. Oh, thank you. So if there's any questions, I will start to answer now. Yes, the notebook will be uploaded right after I finish this talk. A lot of, I mean, some of these features are in 12.2. So if you evaluate, you may not see the same results. All right. Hi, Itai. So I saw you raise your hand. So
Okay, can you hear me?
yes.
Okay, extra security warnings in Big Sur. Um, when are we going to get StreamPlot 3D?
It is under development. So we are actively working on that one because we know it's something people want. So, but I have no promises. Well, thank you very much. Oh, is there any way to get the same scaling in the second vector plot in the first one? Um, yes. So, well, I assume that you're talking about this one, right, Francisco? Um, the same scaling, I assume that you're talking about the same vector length. Um, it is not very easy. You can get so the option vector scaling, besides like the log or automatic and none, it also allows you to oh, does it? I'm not sure if it allows you to specify a custom scaling. Um, oh, I don't think we allowed that for this version. Um, if you do want that, the same sizes, you can use vector sizes to scale them. So vector size, it actually can go beyond 0 to 1. It can go to 2 or something. And that's how you can control that. And you can also have the same density of the vector points that just inside this region. Um, so I would say that the best way to do that is that you have your vector points sampled in both uh, vector plots, and then when you stick them together, they are the same. All right, thank you. So we have an office hour that is going on right now. So if you want to join me there, then I can answer more questions over there. Thank you very much.